Hi, my name is Matt, and this is my presentation on wind energy. Wind energy is a renewable energy resource that can be harnessed to help meet the electrical demand needed to support society's current lifestyle. It can be used in tandem with other forms of renewable energy to help transition away from using fossil fuels. Doing so will help reduce the amount of carbon emissions with its clean energy production. To start the process, solar radiation heats the atmosphere, and due to the uneven topography of the surface of the Earth, different areas are heated more than others. This creates currents that wind turbines can use to turn kinetic energy into mechanical and then electrical energy. The design of wind turbines is a complex combination of various different components that must work together to efficiently produce electricity. The material selection for the turbine blades and tower are critical. Ideally, lightweight materials that are strong yet flexible in order to withstand the high stresses that can occur due to strong winds should be used. A major component that must be considered when choosing materials, structure shape, and control systems are the natural frequencies at which the tower and blades will create vibrations and lead to resonance, which is a potentially devastating scenario that can lead to damaging components at a small or large scale. To avoid this, vibration damping mechanisms such as tuned liquid dampers or pendulum-tuned mass dampers are used to either mitigate vibrations or move the vibrations to a different non-resonating frequency. Vibration-absorbing materials may also be used in the structure to limit the effects. From a safety standpoint, turbines are designed to have cut-in and cut-out power outputs. To ensure that the turbine will not exceed the maximum power and braking capabilities, turning the nacelle and blades with yaw control away from the wind or blade pitch control to rotate the blades and increase the angle of attack, which produces and uses stall to slow the blade rotation, can be implemented. With more surface area, more wind can be used to push the turbine blades, making it better overall, and especially in slow wind speed locations, to have larger bladed wind turbines. The problem for large onshore turbines is that they cause excessive amounts of noise, are a hazard for birds, can cause issues for radar, and can be in the way in a populated area. For these reasons, remote locations are often ideal, but pose issues for both types, especially when transmission lines are needed to transfer electricity to the electric grid. Offshore turbines require lots of planning, coordination of resources, and thought for the construction process. They are either floating or on monopiles, which are towers driven into the seabed, which can cause harm to wildlife. Transmission lines cause issues with the seabed as well, due to the generated magnetic field from flowing current through them. Improvements to current designs include more research into noise reduction methods and materials, a more efficient transmission line system for deep offshore turbines that are highly attractive due to the availability of fast, undisturbed wind, and energy storage methods such as hydrogen, where the wind turbines provide the power necessary for electrolysis to produce the hydrogen. Some future designs and technologies include vertical axis wind turbines for smaller scale urban areas. A few examples of this are the Darius, H. Darius, Helical, and Savonius models. Each of these have reduced noise pollution, slower rotation rates, which are safer for birds, and they require less maintenance. Another type is ducted wind turbines, which mimic jet engines with a duct shape that speeds up the air as it passes through the blades. These can also be used for smaller scale power production. Finally, bladeless wind turbines, they have no blades, no harm to wildlife, limited noise, and less parts that require maintenance. These work by using the vibration caused by vortices in the airflow passing by the tower. Here are my references. Thanks.